Now we're on page 2 of the chapter 8 and 9 AP packet, and we're going to be learning about how to calculate the lattice energy in number from a lot of other information given about the ionic compound. Now there are two methods to approach this problem in lattice energy solving for the number. One is with a picture, and the second method is with Hess's law. This video is going to show you how to do it with the picture, and then the second video after this will show you how to do it with Hess's law. So let's use the picture first to help us understand what's going on. And by the way, this link right here is also on my homework site, and you can click that link to watch another explanation of this with the picture as well. It'll help you put it into perspective. Okay, so let's get the big picture first. I'm going to make this actually a little smaller so we can fit it all here. All right. We're going to start off with writing the salt that we want to form right over here, NaCl. It's a solid. We're going to write down the elements in their standard states from which it is made. It's made from sodium, which is a solid, and it's made from chlorine gas, Cl2. Remember, it's diatomic with Hanoff-Goldbriat. But since we only want one chloride, we're only going to need half of a Cl2. The analogy would be Cl2 comes in a 2-pack. Let's say your favorite candy comes in a 2-pack, and you buy a 2-pack, you would have 2 of them. But let's suppose you only needed one of them. Technically, you only have to pay for half of a package because you'd only need one of them, and then your friend could pay for the other half, and then each of you has one. So we're talking about energy here, okay? The currency of chemistry is energy. When you want to get things done, it's all about energy. So when you change the elements in their standard states into 1 mole of a substance, that's called the heat of formation. You may remember this from last year. We're going to touch upon it again now. So the heat of formation is the heat either absorbed or released to make 1 mole of a substance from its elements in their standard states. Now, what we need to do is we need to also think about lattice energy. Lattice energy is when you form 1 mole of a substance from its gaseous ions. So the ion of sodium is Na+, and it has to be a gas. And the ion of chlorine is Cl-, and that also has to be a gas. So we have to turn sodium solid into sodium plus gas and chlorine gas into chloride gas. And when we eventually go from here to here, that's called lattice energy. Now, along the way, we have to accomplish a lot of things. The first thing we have to do is we have to change this sodium from a solid into a gas. And when you turn sodium from a solid into a gas, that's called sublimation. And then you have to turn the sodium gas into the sodium ion. So that's going to be removing an electron, and we remember from last chapter that that's called ionization energy. So removing the electron is called ionization energy. All right, now let's go turn our attention to the chlorine. We have to split this into a Cl gas. And that Cl gas came from Cl2. So we have to break the bond between the Cl's. See, the Cl's right here. They're attached, and you have to just break that bond. So that's called bond energy. But because we only need one of these Cl's, technically we only have to pay for half the package. So we actually only need half the bond energy for this. And then we're going to have to make the Cl gain an electron to become Cl-, and that, as we know, is called the electron affinity. So from the top of this sheet, you can see all the numbers for these things. Okay, so let's go one at a time. The heat of formation of sodium chloride is negative 411 kilojoules per mole. So that's over here, negative 411 kilojoules per mole. The next thing it tells you is the sublimation is 108. So I'm going to write 108 kilojoules for that. And then it says that the ionization energy is 496. So that's going to be 496 kilojoules. And then it says the electron affinity is negative 349. So negative 349, because remember, electron affinity is energy actually being released. So technically this arrow should go down, but we're not going to go crazy with that. And then the bond energy is 240. So if I only have to pay half of the bond energy, I'm going to write 1/2 of 240. And lastly, we are trying to find the lattice energy. So we're trying to find this. So in order to find that, we need to use, whoops, I went to the wrong page, the lattice energy. We are going to use this highly technical equation that lattice energy equals delta H minus stuff. So all the stuff in red is the stuff. You basically have to add all the red together and then take delta H minus that, and you're going to get the lattice energy. So the delta H is negative 411 minus the stuff, which if you add that all up together is going to be negative 375. So watch your minus signs because you have to minus a negative. And when you do all that, you should get negative 786 kilojoules per mole as your answer for the delta H. Okay, so quick recap. You first make your little map right here. Make your little map that I did in blue. Then fill in all the numbers from this chart in the map appropriately. And then you're going to take lattice energy equals delta H minus stuff. Now just a little warning. Let's suppose that this had been, which we'll see in another example later, but let's suppose this were MgCl2. Right? If this had been MgCl2, just to throw this out there so you've heard it at least, we're going to have 2 chlorides, right? So if you had 2 chlorides, you would actually have to use the whole bond energy because you need both of them. So you'd need this would be a 1, and then if you had 2 chlorides here, then you'd have to have 2 times the electron affinity because 2 of them would have to gain an electron. All right? And then if you had Mg over here, Mg solid going to Mg gas would have been the same type of thing, but you would have had a first ionization energy to make it a +1, and then you would have had a second ionization energy to make it a +2. So you would have had 2 ionization energies, which they would have told you in the chart. So all I'm trying to get you to see is that you have to pay attention to what the formula of the salt is and appropriately add in things into your map that you would need. In the next video, we're going to see how to do the same problem but using Hess's law.